Here we have Olympiad math problem. Okay, let's go to the question. If x equals to 1 positive square root of 5 over 2, what is the value of x to the 12th power? Here we have the value of x, that is 1 positive square root of 5 over 2, and we have to get the value of x is raised to the power of 12. Okay, now let me take the given value of x, that is x equals to 1 positive square root of 5 over 2. Let me multiply both sides of the equation by 2. Then this 2 will cancel out. We get 2x equals to 1 positive square root of 5. Let me subtract a 1 from both sides of this equation. Then positive and negative 1 will cancel out. I am getting 2x negative 1 equals to square root of 5. Now let me square both sides of this equation. Then we have square on the right side. Here this square and square root will cancel out, and it is in the form of a negative b the whole square. We can use the algebraic identity, that is a negative b the whole square equals to a square negative 2ab positive b square. We can use this identity to get the expansion of the square of the binomial we have over here. Okay, now let me get the expansion. Then we get 2x a whole square, that is a square negative 2 times a is 2x, and for b we have 1 positive b square, we get 1 square equals to 5. Okay, here two values are multiplied and there is a common exponent 2. So we can take this exponent 2 separately for this one and this one. Okay, when I take this exponent 2 for this 2, I'm getting 2 square. The value of 2 square is 4. And when I take the same exponent for x, I'm getting x square. Negative 2 times 2x is 4x. 4x times 1 is 4x. Positive 1 square is 1 equals to 5. Okay, now let me subtract 5 from both sides of this equation. Then positive and negative 5 will cancel out. We get 4x square negative 4x. When I combine these two values, I'm getting negative 4 equals to 0. Okay, let me divide each term of this equation by 4 because everything is a multiple of 4. Okay, then this 4 will cancel out. Here 4 will cancel out. And here 4 will cancel out. Then we get x square negative, let me write over here x square negative x and negative 1 equals to 0. Now let me add x to both sides and also 1 to both sides of the equation. Let me do it. Then this negative x positive x will cancel out, negative 1 positive 1 will cancel out. I'm getting x square equals to x positive 1. Now let me take this x to the 12th power, and this x to the 12th power can be written as x square raised to the power of 6. And already we know the stuff for this x square, that is x positive 1. We can plug in this x positive 1 for x square over here. Then I'm getting x positive 1 whole to the 6th power. And further, it can be written as x positive 1 whole square raised to the 3rd power. And we can get the expansion of the square of this binomial using the algebraic identity a positive b the whole square, that is a square. That means x square positive 2ab. 2 times x, and for b we have 1 positive b square means 1 square. Okay, so this is the expansion for x positive 1 the whole square, and we have to take this exponent 3 as it is. Okay, let me continue over here. Now we have x square positive 2x positive 1 square is 1 whole to the 3rd power. And for this x square, we can plug in this stuff x positive 1 over here. Then we get x positive 1 positive 2x positive 1 whole to the power of 3. Let's combine the like terms over here. Then we get 3x positive 2 whole to the 3rd power. And it can be written as 3x positive 2 whole to the 2nd power times 3x positive 2 whole to the 1st power. And whenever we have exponent 1, we don't have to consider. And we can expand the square of the binomial over here using the algebraic identity a positive b the whole square. Then we get 3x whole square positive 2ab. That means for a we have 3x and for b we have 2. Positive b square. For b we have 2, that is 2 square times 3x positive 2. Okay, here when I simplify this one, that is 3x whole square, I'm getting 9x square positive 2 times 3 is 6x. 6x times 2 is 12x positive 4 times 3x positive 2. And here for this x square over here, we can plug in this stuff x positive 1. Then 9 times x positive 1 positive 12x positive 4 times 3x positive 2. Okay, now let me continue on the next page. So we get 9 times x positive 1 is, when I distribute this 9 to this x and positive 1, I'm getting 9x positive 9. Let me write over here 9x positive 9 positive 12x and positive 4 times 3x positive 2. Okay, let me write over here. Okay, now let's combine the like terms over here. 9x positive 12x is 21x, and when I combine this 9 and 4, I'm getting 13 times 3x positive 2. Okay, now we can multiply these two binomials using FILE method. When I multiply the first terms, I'm getting 63x square. Now we can multiply the outer terms, 21x times 2, that is 42x. Let's multiply the inner terms. 13 times is 13 times 3x is 39x. And when I multiply the last terms, 13 and 2, I am getting 26. Then we get 63x square. And when I combine this 42 and 39, I am getting 81. That is 81x, positive 26. Now for this x square, we can plug in x positive 1. Already we got this result for x square, positive 81x, positive 26. Okay, here let's distribute this 63 to this x and positive 1. Then I'm getting 63x, positive 63. Positive 81x, positive 26. Okay, let me continue over here. Now we can combine this 63x and 81x. When I combine them, I am getting 144x, and when I combine this 63 and 26, I am getting positive 89. In the question, we have the value of x, that is x equals to 1 positive square root of 5 over 2. It's over here. Okay, now what we can do is that we can plug in this value for x over here. Then we get 144 times 1 positive square root of 5 divided by 2, positive 89. Okay, here 2 goes into 2 1 times and 2 goes into 144, 72 times. We get 72 times 1 positive square root of 5, positive 89. Let's distribute this 72 to this one and this one. 72 times 1 is 72, and 72 times square root of 5 is 72 square root of 5, positive 89. Okay, when I combine this 72 and positive 89, I'm getting 161. Then we have positive 72 times square root of 5. Okay, here I got the value of x to the power of 12, that is equal to 161 positive 72 times square root of 5.